Okay, we're going to look at the towers of Hanoi problem we did in class. The basic idea was we've got these three towers, so we're going to call the towers A and B and C. And the idea is we start with n rings on tower A. So I have 1, 2, 3, and down to say n minus 1, and then n. And I want to get all those rings eventually from tower A to tower B. We want to do it recursively, and we saw that the basic idea is that first we're gonna, in order to do that, we have to be able to free up that bottom ring, this one down here. So we have to somehow transfer these n minus 1 rings off of tower A, and we want to get them to tower C. So the algorithm is going to basically call the three towers the from tower. In this case, the from tower is A, and the two tower is going to be B. And the tower that's neither the from nor the to on any particular execution of the algorithm, we're going to call the extra tower, the one that's neither the from or the to. And we wrote the following pseudocode in class. We had a function called move. Here's the pseudocode called move. And move had the parameter which the tower from, the tower to, the tower extra, and n was the number of rings. And so the base case we saw, we did this in class, the base case was that if n is equal to 1, then there's no recursive call at all. So if n is equal to 1, then all we want to do is we said transfer the ring n from the from tower to the to tower and return. Right? That was the base case. So if we simply say go from A to B, move 1, they'll just be move that ring 1 and we're out of there. But let's say we have more than that. Say we want to move 100 rings. So then we have to move the first 99 from A to C. But in general terms, we want to move from the from tower to the extra one, right? In order to free it up so we can get the 100th one, the bottom one, to tower B. So then what we do is, the second step, if the base case is not true, is we're going to call this function move recursively. And we're going to say like this. We want to go from the front tower to the extra tower. And we want to, the third parameter is going to be the to tower. And we're going to be moving n minus 1. In this case, that's going to take the top n minus 1 and bring them from here to here. And the configuration will basically look like this, right? So we're going to have 1 to n over, we're going to have just n down here on the bottom, and will be here. And 1, 2, all the way up to n minus 1 will be here after call on step 2. At that point, we're ready to take this ring here and transfer it over. And that's not a call on the function move. Simply say transfer it. And we saw when we actually write the program, that'll be basically an output statement. We're going to say cout as we saw in class. So step 3 is again a call to transfer the ring n from the from tower to the to tower. At that point, n will no longer be on tower A, which was the original from tower. It's going to be erased. It won't be here anymore. The tower still will. And n is going to be here. And we still have to move these guys back, right? The ones on this tower here. So we have to call move to bring these n minus 1 and put them on tower B. So that's another call on move. And we're going to say we're going to go from, this was originally this was the from tower, this was the to tower, this is the extra tower. So we're going to go from the extra tower to the to tower. So the third parameter is going to be the from tower. And we're going to be moving n minus 1. When we finish that, we're going to have a situation that basically has no rings on C and no rings on A, but we're going to have all the rings on tower B, and we're finished. And so therefore we say at this point, we say return. Okay, that's basically the idea. Now the question is, what happens when we run this program? We actually, of course, we have to run it by making a C++ program out of it. But if we try to simulate the algorithm, let's see what happens if we start with 3 rings over here, and we want to call the function move. We're going to call move, and we're going to say we're going to go from tower A to tower B. Tower C is going to be the extra tower, and we want to move 3. Let's check out the first couple of first couple of moves. Specifically, we want to see what happens on the activation stack when this algorithm executes. So the first question is, what does the activation stack look like? So we saw in class that the activation stack basically consists of all the formal parameters. In this case, we have from to extra n, so there are 4 parameters there. All local variables, well, there are no local variables in this function, plus the return point to return to, which point in the algorithm to return to after we finish executing a substep. So that means if we want to draw the activation stack, it basically looks something like this. The activation stack is going to have the following in it. It's going to have one slot for the from tower, another slot for the to tower, one slot for the extra, one slot for n, and it's going to have one slot for the return. In other words, what step do we go to when we return? So if we now execute this here, move, let's see what's going to happen. Let's actually try to work this thing out step by step. So the first thing that's going to happen is we're going to be calling move. So it's going to populate the activation stack, the activation record, and it's going to say I want to go from tower A, that's my from tower, to tower B. C is going to be the extra tower, and I want to move 3. And I'm going to call this from the main program, so when I return back, I'm going to basically be returning to wherever I was called for, to the main. Okay, so when the recursion happens, the first thing that happens is the activation record gets populated, and then the program starts to execute. So now we come here in step 1. So it's going to now say, essentially like this. By step 1, right, the first thing that happens is step 1. Let me get a different pen for a moment. Let's take a different color. Say something like this. So the first thing is now step 1. Step 1 says we're going to call move. This is what we did just now. We're going to call move for A, B, C, 3. Now once we do that, we're going to come into this algorithm at step 1. But the first thing that's going to do is it's going to ask what the value of n is. Is n equal to 1? Well, currently the value of n is equal to 3, so that's going to be false. So now we're going to end up on step 2. Right? We start on step 1. We're going to end up on step 2 of the original call on move. What step 2 says is we're going to call move again, but this time we're going to go from the from tower, which is tower A, and the second parameter is going to be the current value of the extra tower. Well, the current value of the extra tower is C, right? So we're going to go from A to C. The to tower is going to be B, and n minus 1 is the parameter, so it's going to be 2. Those are the 4 parameters being passed in. And if you look at this, basically what it's telling it is that in order to accomplish the moving of 3 rings from A to B, what it's going to have to first do is move 2 rings from A to C, right? And so every call on the recursive function is going to result in a new record on the activation stack. So the activation record is going to look just like the other one. And we saw the recursive call is going to result first in populating the activation record and then going to do the algorithm. So this is going to say A, right? We just populate it with the parameters as they passed along, A, C, B. There's going to be 2. Now the question is, where do we return to? In other words, after we execute this particular call, where do we return to? Well, since we're calling from step 2 in the algorithm, when we come back, we're going to come to step 3, right? Just like in any program. So the return point is going to be to step 3. Okay, so we've populated the activation stack, and now we're ready to, the activation record, now we're ready to go into the program again. So we come into step 1 of the program, and again we ask, is n equal to 1? And the answer no, is n is not equal to 1. N is not equal to 1, n is equal to, the current value n is 2. So what happens? We again call function move, right? So this is now by step 2, but by step 2 of what? Of the previous call of move ABC2. We're going to call move again. But what happens when we call move? We're going to have to populate the activation record. So the system creates a new activation record for us. And what's going to be called? So it says move of the from tower. What's the current from tower? It's going to be move of the current from tower. From tower, I just read it off of here, is A. And then the next one is the extra tower. The current extra tower is B. And the one that's neither A nor B is going to be the third one. So that's going to be that's T, which is C. And how many? It's n minus 1. Well, n is currently 2. N minus 1 is going to be 1. So it's going to make that call. It's going to call move A, B, C, 1. So this is going to be A. This is going to be B. That's going to be C. That's going to be 1. And what's the return point? Well, again, since we're calling from step 2, we're going to have to return to step 3. Okay, so we've populated the activation record. And now we are ready to, this thing should say 3, right? And now we're ready to execute the program. So we come in and we ask if n is equal to 1. Well, that's true. So this is going to be by step 1, right? By step 1 of this call, we're going to say, is n equal to 1? And in fact, yes, n is equal to 1. It's the n on top of the activation stack. So we're going to do a transfer. Right, what everything in step 1 says, we're going to do a transfer of the ring n, in other words, of ring 1, that's the value of n, from the from tower to the to tower. Well, the from tower is tower A, and the to tower is tower B, so that's going to result in moving the ring 1 from the from tower to the to tower. It's going to put ring 1 over there, and of course it's going to take ring 1 off of there. Right? So that's what happens. This is the first time that anything happened. And in fact, of course, anything can be moved only when it's on the top, and we see that happens right over here. Now, what happens after we do this transfer? We're going to transfer ring 1. We're going to transfer ring 1 from the tower from tower A to tower B, right? From tower A to tower B, and then what happens? And then return. Well, what happens when we return? What does return mean? Return means two things. Return means, number one, we're going to take the current top of the activation stack and we're going to pop it. We're going to get rid of it, and we're going to return to the previous level. Right? We're going to turn to this previous level over here. This is going to be the new one over here, and we're going to return to step 3 of the previous level. So it's going to look like this. We're going to get rid of the top one here, just like that. This comes off, no longer here, and we're going to return to step 3 on the previous one. And that makes sense, right? We're going to be over here on step 3, right? Step 3, which makes sense. We just did step 2, and now we do step 3. What does step 3 say? Step 3 says transfer the ring n. So this is going to be, again, transfer ring n. What is ring n? It's the current value over here. This is ring n. So transfer ring 2 from where to where? From the from tower. My current from tower is A. And my to tower is C, so it's going to go from A to C. That's going to take this one here, and that's going to bring it from here and deposit it here. So when I do that, there's going to be a 2 here. The 2 is taken off of this. 2 is no longer going to be on there, and this system looks like this. 3 is going to be on A, 1 is going to be here, 2 is going to be here. Now what do I do after step 3? Well, after step 3, I go to step 4. Right over here. And what does step 4 do? Right, notice it's this thing here. I've been indenting it appropriately. Step 4 says, let's do another call on move. And what's the call now? It says go from the extra tower to the to tower. Well, what's the extra tower? The extra tower is B. Right, so we go from tower B to the to tower. The to tower is tower C. So I'm going to go from B to C. Right, to move from B to C. From here, it's going to try to move to here. Which ring? And the from tower is going to be A. That's the third parameter. So B to C and A is that. And how many am I moving? I'm moving n minus 1. Since the current value of n is 2, n minus 1 is going to be 1. And it's basically telling me to move ring 1 from the B to C. It's going to take this thing over here and basically move everything off so I can free it. Okay, I'm going to leave the rest as an exercise, but that's basically what happens as this program executes.